Kia ora te whānau. We're going to start looking a little bit at motion and getting these sprites to move around. Last video we took a look at getting this this game up and running, getting some collisions happening, getting some score happening, and we got our player to follow the motion of the mouse, and we got it to go exactly where the mouse was. That can be great. But I want to show you another way to just give it a little bit more interest, to make it seem a little bit nicer. And that is, take a look here. As I bring my mouse back onto the screen, just notice how my player now isn't quite where my mouse is. There's just a tiny little delay in getting my player to follow my mouse, and I quite like that. And I can control that amount of delay as well in my code. I can set it to be really, really strong, or I can set it to be really, really delayed. So say maybe you were doing a spaceship game, or maybe you were doing a racing game where your sprite was accelerating towards where the mouse was, then that can be really nice. So rather than being absolutely locked in to where the mouse position is, it slowly shifts to where that mouse is. Look at that glide right towards the end. Isn't that nice? Okay, cool. What's going on here? This is something called a linear interpolation. Oh my god, what a word, what a phrase. Whoa, hang on, linear interpolation. What on earth are you talking about? Okay, let's go to, whoa, not there. That's for later. Jamboard. Okay, what's going on? We have our window, and let me just adjust everything. Okay, we have our window. We have our player position. This is going to be horrible. I'm drawing with my mouse, so forgive the artistry. I have my player position, and I have my mouse position, wherever that happens to be. And we're going to linearly interpolate between these two. Let's do it in one dimension, and then it's nice and easy to think about it in two dimensions. So let's pretend for a moment it's one dimension. I'm going to draw my player over here. Whoa! And here's my mouse. Oh, yeah. Art. Absolutely. Love it. Here's my mouse, and all we've got is one axis between one and the other. Okay. So let's say this is the number line. Maybe here's 0. My player is currently at 4. Player is currently at 4. My mouse is currently at 20. I'm not making this math easy for myself. Okay. Now I want to shift my player a little bit of the way across from 4 to 20. I'm going to cover not the whole distance. I'm not going to teleport my player straight from 4 to 20. I'm going to cover a little bit of that distance. And then in the next frame, I'm going to cover a little bit of that distance again. And then a little bit of that distance and a little bit of that distance. In fact, in each frame, what I'm going to cover is I'm going to cover 10% of that distance. So what's the difference here? Difference is 16. So in the first frame, I'm going to cover 1.6 pixels. So then I'm going to be here at 5.6. Then in the next frame, how much have I got to cover? Well, 15. So I'm going to only cover 1.5. And then I'm going to end up here. And then after each frame, I'm actually going to start slowing down. Right? As I get closer, let's say I get to 15. What's left? Well, there's only 5 pixels left now. So I'm only going to travel half of one of those each frame. Maybe I should have made these numbers 100 times as big. So maybe it's at 1500 and 200 or 1500 and 2000 or whatever. The point is each frame you're covering 10% of that remaining distance. So if I can do that here in the x-axis, and I also do it this way in the y-axis, then I end up traveling a little bit in this direction, and a little bit in this direction, and a little bit, and a little bit, slightly less each frame. Oh, trying to draw small arrows with the mouse, hey. Towards the mouse. I'm going to travel towards the mouse, but slightly less and less and less and less each frame. The good thing is that the further away that your character is, the faster they cover up that distance, and then they're going to slow down and slowly approach it. It's a really nice little slowing down effect. Okay, let's code it up. Cool. Let's go back to the one that we coded up last lesson. Let's get rid of some things that we don't need for today. I'm just going to make a copy of this. So let's copy, paste, sprites copy. Let's rename it linear interpolation, which is fondly known as Lerp, which I think is one of the best shortenings of a fancy term to make it sound like a silly term. I love it. I love it so much. So we're going to Lerp. Lerping is fun. Okay, what do we need? We don't need a score. Score can go today. Bye-bye. We actually don't need coins. Coins can go today. Let's make our mouse visible. So it's going to be true. And our title is going to change to Lerp. Ooh, last video, I had a bug, but I've also got IntelliSense on, so I was saved from the bug. This line of code was automatically generated for me, and I was saved by the bug. The bug was down here on drawer. I said start render rather than arcade.startRender, and it should have come up with, hey, start render's undefined. But because I've got these extensions on Pylance, is what I'm using at the moment, it went, ooh, I wonder what he means by that. Does he mean arcade.startRender? Maybe I should just pull that in from the library and, well, we'll just forget about it all. So I was saved from that bug. If you were struck by that bug and you couldn't figure it out, I'm sorry. But that's just what happens. So we'll delete that code. Okay. Coins. Don't need coins today. Bye-bye, coins. Go away, coins. Don't need you today. Make it a little bit simpler. Coin list can go as well. Okay. Coins all going. All of the coins are going. Okay. And on update, we can pass at the moment. We possibly don't need it, but I'm just going to pass. What does pass do? Of course, it just means do nothing, but you have to put pass in, or else these lines of code down here won't know what's going on. They're going to complain at you. Your code's not going to run. Okay. Right. What do we need? On mouse motion, we need... no, we don't need on mouse motion. Actually, what we need is we need to delete that as well. Don't need on mouse motion. Okay. Update. So every frame we want to change. Oh, that's annoying me. Every frame we want to change our player's position a little bit towards wherever the mouse is. Luckily, Python Arcade actually has an inbuilt mouse X and mouse Y variable that we can access whenever we want. And it also has a built-in Lerp function, so we don't have to make our own. So what we can say is self.player center X. Thank you. Self.player.center X is going to equal arcade.utilities.lerp. And we're going to so V1, V2, and U. What are those things? They are the first number that we're going to that we're hitting from, the number that we're hitting towards, and the amount that we're heading towards it by. Each frame, how much we're going to change the first number by the second number. So how much impact is that second number going to have on our first number? Is it 10%? Is it 100%? Is it 0.00000001? Of course, not percentage. These are all floats. So 0.1, 10%. Okay, so the first number is going to be self.player.centerx, of course. And the second number is going to be arcade, I think arcade with self dot. And it's self dot underscore, and there's this hidden property called mousex, which is being taken care of all the time for us. And we're going to change it by 0.01. And same thing, except now we're just going to do it with center Y. By the way, those hidden properties, very, very useful. Right, let's run it. There we go, thinking about it. Game has no attribute score. On line 70, line 22. Line 22, not drawing the text today. You could have left the coins in. It wouldn't have mattered. In fact, it might have made it a little bit nicer for you. I just wanted to show this lerping. So just wanted to get rid of those. Cool, look at that. We now have motion towards the mouse, which is not directly tied to the mouse, absolutely at the mouse position every frame. It heads towards it. Now, we can change this value. We can make this 1/10 of the strength. And there we go. A slow lerp. Heading towards the mouse each frame. Getting slower as it approaches, but still heading towards it. Maybe if you're doing an accelerating game, like a rocket ship or something, that's useful to you. Maybe we can make it super strong. So it's just going to have a really subtle lerp effect. Let's check it out. There you go. That's nice. I like that a lot. It's got this nice little animating feel, but it feels just a little bit more sophisticated than just using mouse X, mouse Y. There you go. That's lerping. Everyone loves it when you lerp. There you go. Very, very useful. Very cool. It can get you out of a couple of sticky situations. It can also make you have a little bit more of a sophisticated game and a little bit more of an elegant feel. There you go. Lerping done. See you in the next one.